turning on our remotes. Let's talk about React Router. Oh, yeah. Excited? Huh? Oh, okay. What's that? Nope. Nope, I didn't. Didn't do it yesterday either. I know. Class hasn't really started yet, right? I'm sorry. Week 3, day 2. Woo! All right. Yeah. So, what is React Router? Who knows how to read?
I don't.
All right, Sadie, tell us all about it. Hush! Sadie is talking.
Okay, React Router is a JavaScript package that allows our UI to stay in sync with our URL. It allows us to bring specific components based on which routes match or don't match the current URL.
Gosh darn right it does. Yes, React Router for getting our UI in sync with our URL. So, as Lewis pointed out, we're on one page this whole time. We're hiding and showing different components, but we're always on the same page. These are single-page apps that we make with React and other similar libraries and framework. We never actually leave index.html. We're just hiding and showing different things with JavaScript. So it would be cool if we could actually change the URL despite the fact that we're never actually leaving the page. And we can with client-side routing. Anybody ever used a different, any kind of other web framework that has routing besides React? Okay, cool. Well, you remember the diagram from the first day? Showed a laptop over here, the question mark on the right, and we sent a request, then eventually sent a response. Well, we only have one page that we're getting index.html every time. So if we start requesting different URLs, things are going to break unless we configure our web server appropriately. So we'll configure our web server appropriately, and we'll just have it give us index.html back every single time, and we'll use JavaScript to figure out what the heck's going on with our URL. So that's what React Router is going to make easy for us. To get started with it, you add it to your project. You don't need to do this right this second, but yarn add React Router DOM would do it. React Router DOM, because this is the web version, there is always React Native, right? So React Router DOM, that'll download it, put it in your node modules folder, and add it to your list of dependencies in package.json. And then in index.js, where we just replace that one single DOM element with our app component, we'll wrap that app component in a router component that we get from React Router. And then routing is available in our app. So we start by defining one or more routes. So here's what routes look like. Let's have a look at that first one. It's a route component that we import from React Router. It has a path, and it points at a particular component. And it says very simply, if the URL matches /widgets, show me the component widgets. Now there's a couple things different about that second route. First, it says exact. So that first example, /widgets /32 would still match. That is still a match for that first route because it is still /widgets /something. In the second example, /stuff /48 would not match because it says exact. So adding that exact prop makes it not match /whatever you say there /something else. So exact prop. The other difference, instead of pointing at a particular component, we have a render prop. And the render prop takes a function that is a render function, returns from JSX. So can anyone think why we might need to use the render prop instead of component? What could we do in the second example that we can't do in the first example? Yeah, but what if we had a prop that had plenty of HTML in it? We're still going to have to wrap them in something. Yeah. What can we do differently, though? How about passing props? You can pass props in the second example, right? Can't pass props in the first example. So if you have to pass any props, you're going to have to use a render prop instead of component equals whatever the component is. So there are also link components included in React Router, link and navlink. Under the hood, they just generate a href like you'd expect, but we say link to instead. Difference between link and navlink. Navlink adds a class of active to the link if you're already on that page, which is something you do a lot in code to style the current page differently from the others in your menu. So navlink does that for us. We'll see an example. We'll see examples of all this stuff, of course. So another thing that makes things a little more interesting is when you have a param in your route. So let's look at this one. Route path equals /about/: name. So this lets us basically put a variable in the middle of our path. So that means /about/ anything. And whatever you put there will be assigned to the param name. Now that they've stopped, we're probably going to want to open that again. It's going to get real hot. So that is a path with a param in it. So the link above, /about/Bob, that will match that route. So it'll take us to the component user about. So when you're using a route to get to a component, 3 props will be passed in automatically: history, location, and match. We won't really talk about location. We're not going to use it, but history and match we will talk about. And match we use to get params. So you'll see it says, this is a page about props.match.params.name. So that will say this is a page about Bob. So because we got to user about by going through a route that has a param in it, you can get to that param through props.match.params. And since we got there by going to /about/Bob, you might need to know which name was in place of :name. And this is how you do it. Props.match.params. Whatever the name of that param was. Again, we'll see examples. So 3 props automatically get passed in: history, location, and match. That was match. We can get params out of there. And this is history. Who can tell us about history? Who knows how to read? Mimi, you said you knew how to read earlier.
Yes.
Is it still true?
History, yes.
All right.
History keeps track of all the user's navigation over time. It can be used to programmatically navigate without using links. There are many useful history methods: push, go back, go forward, go in, block.
Yes. True story. So sometimes you need to navigate between pages programmatically instead of by clicking on links. If, for example, you've submitted a form and now you want it to go to a new page. So for that, you might have to use the history object. So the history API is something that was introduced in HTML5, and it's pretty wonderful. And it's what makes client-side routing as we use it these days possible, because you can actually change the URL without actually leaving the page. So sometimes you need to do that. And for that, you could use history push. That'll push a new thing onto your history. There is a pop, I believe. Go back. Goes back to the previous page, just like hitting the back button. Go forward, just like hitting the forward button. Go in, pass a number in there. It'll go back that many times. So that, real quick, is React Router. And we'll take a closer look at that here in a minute. And in this next project, we're going to be looking at one other thing that's unrelated to React, but that's very handy for talking to APIs and stuff like that. And that is fetch. Yes, ladies and gentlemen, HTML still trying to make fetch happen. Yes. So, who knows how to read? Tell us all about it, Conboy.
Fetch. The Fetch API provides a JavaScript interface for accessing and manipulating parts of the HTTP pipeline, such as requests and responses. It also provides a global fetch method that provides an easy, logical way to fetch resources asynchronously across the network.
Gosh darn right it does. Yeah, async. So, making HTTP requests without refreshing the whole darn page. I can just make HTTP requests in the background, get the results, do something with them. Great for talking to REST APIs and so on. You heard of REST APIs? So, services that let you talk to them remotely over the web. So you can pull some weather into your app or pull in Google Maps or whatever. Fetch is a pretty handy way to do that without using the old school AJAX way of doing this. Here's a very quick example of the syntax. Just call fetch, pass it a URL, it does the thing. You want to do something with the results, you got to wait because it happens asynchronously. It runs in the background, just like what we did yesterday. Remember, we saw this .then business before. So fetch returns a promise. So you got to wait for it to finish. So by calling .then and passing in a callback, it'll call that callback as soon as it actually finishes fetching. So in this case, we get the response. We happen to know it's JSON being returned from that API. So we call response.json, which itself returns a promise. So again, we have to call .then and then say what we want to do with it. So we want to console log it. Then at the end, we can catch any errors. So we'll see this stuff in action here very shortly. Questions before we get started? Yeah. No, you can call it whatever you want. But the thing that's going to get passed in there is an error that it caught or an exception. Yeah.